this chapter, that is electricity. Okay. And what we are going to study in this chapter, let me explain you first. We're going to study first that what is electric current. Okay. Electric current and circuits. What are circuits? Okay. Electric potential and potential difference. What is electric potential and what is electric potential difference? Okay. Then circuit diagram, Ohm's law, relation between the Ohm's law and potential difference. Okay, we're going to discuss factor affecting the resistance, and that depends on the conductor, that we're going to study in this chapters. Okay, so let us start studying this chapter. Okay, so first of all, if I talk about this electricity, that what is electricity? What is electricity? So you know that electricity is a form of energy. Okay, it is a form of energy, and we can say that the rate of flow of electrons. Okay, we can say that when the electrons flow, or we can say that electricity is the energy that is produced by flowing of electrons. Okay, when the electrons flow, okay, vibrate, then electricity is produced. Okay, understood? So what is electricity? Either the electron vibrate about its mean position, or electrons move from one position to another position. Okay, so if the electrons are moving in a particular direction, okay, for example this way, okay, then we say that electric current is flowing through it. Okay, we can say that electric current is flowing through it. So in simple word, if I'm going to explain you that what electric current is, or what is electricity. So electricity is a form of energy that is produced by flow of electrons, or by vibration of electrons. When the electrons vibrate about its mean position, then electricity is produced, electric current is produced. Okay, got it? Understood?
Yes, sir.
Okay. So let's move further. Moving further. So talking about this electricity, note it down that it is a form of energy which is generated by flow of electrons. Okay. And who discovered electricity? So we specifically don't know that who discovered electricity, electric current. There have been so many theories that say that electricity, we just have the rules, or we just have the history that how electricity means in ancient time how electric current was used, but we don't know specifically any person name that who discovered electricity. There are certain scientists, famous scientists, okay, and who give the relation between electricity. Okay, just for example, Benjamin Franklin, he proved that the clouds in the earlier ancient time, we see that if there is a lightning taking place in the clouds during the rain, then the people of ancient time think that it is the means the god is angry with us, and that's why he is showing his anger in the form of lightning. But Benjamin Franklin proved that it is that electric current is due to we can say the lightning occur due to the mixing of clouds of a positively charged. Okay, so in 1972, Benjamin Franklin did a kite experiment and help in giving the relationship between lightning and the electricity. So please note it down. Note it down. Done.
No, sir. Done, sir.
Done?
Yes, sir.
Not responded. Amma, done?
Sir, can you hear? Sir, can you hear?
Okay. Oh, your voice is not coming. Wait a minute. Speak speak something.
Sir, can you hear me now?
Oh, wait a minute. So done this time?
Yes, sir.
Okay. So let's move further. In 1930s, we are just taking a look of what the electricity. Okay. So in 1930s, there was some batteries was found in Baghdad. Okay. Roman Persian, and we can say that together now today's we call it Baghdad in Iraq, sorry. Okay. So there we found the batteries. They were the batteries, okay, of the Persian Empire. So in 600 BC, ancient Greek discovers the charge between the embers and the fur. When we uh, rub a ammonite rod, okay, on a fur, then it get charged, okay, to balloons. When we rub together, then they got charged. So we simply say that that there were different means theories that shows us, or we can say that the different lectures or different sites were observed by the scientists that proves that we were studying, we have a great connections with electricity during the ancient times, okay, past early times. Now moving to the next point here is that electricity we have divided into two parts. One is the static electricity and another one is the current electricity. Static electricity is not in our syllabus, so we are not going to discuss. We are just going to discuss the current electricity. And current electricity is of two types. One is direct current and alternate current. Okay. Let me call it. Okay. So direct current, it is not also in our syllabus. We are just going to discuss the current electricity. Okay. The both the parts we will going to discuss. So note it down, electricity. Make this chart. Then we're going to discuss. Make this chart. Done.
Yes, sir.
Now moving to the next part is that what is electricity? Okay. What is electricity? So if I talk about that, what is electricity or what is electric current? What is electric current? What is electric current? So we can simply say that the rate of flow of charge is called electric current. Okay, the rate of flow of charge is called electric current. Okay, and what is charge? Charge. What is charge? Okay, if I talk about the rate of flow of charge is called electric current. So you know that everything. Ammar, are you there in the class? Ammar, are you there? Ammar is not
Yes, sir.
responding.
One second. Yes, sir. My brother. Yes, sir.
So if I'm talking about that, this is an atom. An atom is made up of, it consists of positively charged nucleus and negatively charged electrons. Okay, negatively charged electrons. So if I talk about that, when electrons flow, means since we can say that electrons are going to have charges, electrons are going to have charges, and when electrons flow, the electric current is produced. Okay, so we can say the rate means divided by time. The rate of flow of charge is called electric current. What is called electric current? The rate of flow of charge is called electric current. Electric current. So we can say that electric current is equals to charge divided by time. Charge divided by time. You understood? So if I talk about this one, that electric current when divided by charge, it gives you time, or divided by time, it gives you electric charge. So we can write it I is equals to Q by T. What is I? I stand for electric current, Q start different for charge, and time different stand for T and for the time. Okay, T stand for the time. Okay, you understood? Got it?
Yes, sir.
Okay. So please note it down. The rate of flow of charge is called electric current, and then I can be defined as the unit for charge is coulombs, and T time is seconds. So we can say that its SI unit I for SI unit is coulombs per second, which is togetherly called ampere. Okay. So note it down. Coulombs per second. So SI unit is the SI unit of charge is ampere. The SI unit for charge is ampere.
Done, sir.
Done. Now, if I ask you that what is the definition for 1 ampere current? Define, if I ask you that define 1 ampere current. Define 1 ampere current. So how can you define 1 ampere current? The question comes that define 1 ampere current. So you know that I is equals to Q upon T, and T stand for charge. Sorry, Q stand for charge and T stand for time. Okay. So how can you get this value of 1? When you have 1 coulomb charge flows through a conductor for time 1 second, you will get 1 by 1. Okay, so we can have a definition that when 1 ampere can be defined, or we can say that when 1 coulomb charge flows through a conductor for the time 1 second, it is said that 1 ampere current flows through it. Note it down. When 1 coulomb charge flow through a conductor for the time 1 second, it is said that 1 ampere current flows through it. Note it. Done?
Yes, sir.
So if the next question here is calculate the charge flows through a conductor when 2.5 milliampere current flows through a conductor in 2 seconds. Calculate the charge flow through a conductor when 2.5 milliampere current flows through a conductor in 2 seconds. Amar, are you doing?
Sir, is milliampere and ampere the same thing?
Yes.
Is milliampere and ampere the same thing?
No. 1 milliampere is equals to 10 raised to the power minus 3 ampere. So if I have 2.5 milliampere, so it means 2.5 into 10 to the power minus 3 ampere. 10, okay, 2.5 is equals to 2.5 into 10 raised to the power minus 3 ampere.
So can you hear my voice properly?
Yes, your voice is coming.
Okay. Because my laptop is getting stuck. So.
Sir, charge is 5 into 10 raised to negative 3.
Wait a minute. Yes, what are you saying?
Charge is 5 into 10 raised to negative 3 ampere. Sorry, not ampere, coulomb.
Yeah. Let me check. You can write it. I is equals to Q by T. Then is this T will goes to that side to multiply with this to calculate the charge. So we can
So
write charge.
can I rejoin the meeting?
Why?
So my laptop is getting stuck, and your screen is not visible for me now.
Okay. Let's join it. So charge is equals to I. We can say the charge is equals to I into T. Current into into time. Okay. So current is given, that is 2.25 into 10 to the power minus 3, and time is given, that is 2. Okay, so you will get 2 into 2.5, you will get 5 into 10 to the power minus 3 coulomb. Okay, is that your answer?
Yes, sir.
Okay. Now, if a question comes to you that how many coulombs of charge, how many electrons constitute 1 coulomb charge? How many electron constitute a coulomb charge? Yeah, 1 coulomb charge. 1 coulomb charge. So you know that if it is given that we know that Q is equals to N into E. Okay, this is the formula for this one, because the charge that is carried by electron, that is, it is 1.6 into 10 to the power minus 19 coulomb. Okay, that is the fixed value. We have to memorize this one. Okay, so if I'm saying that Q is equals to N into E, so what does it means? It means that if we are having 2 coulomb, 2 electrons, then they will have 2 into the charge of E, this one. If I am having 1 lakh electrons, okay, then the 1 lakh electron will constitute how much charge? That is 1 lakh into 1 charge of 1 electron. Okay, similarly, if I'm asking that how many electrons will constitute 1 coulomb charge, so you don't know the number, this is your write the number here, and then charge of an electron is 1.6 into 10 to the power minus 19, and here you total charge is 1. So the number of electron here will be 1 upon 1.6 into 10 to the power minus 19. Please calculate the value here. Calculate the value of N, the number of electron that constitute 1 coulomb charge. You understood this formula? Q is equals to N into E.
Yes, sir.
Okay, note it down, and then
Done, sir.
okay. So what's the answer? What's the answer, Simon?
Sir, I had to solve that fraction.
Yes, you have to calculate. Yes, you have to calculate. Done. How will you be able to calculate? Let me help you.
The answer is 0.6 into 10 raised to 19.
Yeah, it is correct. So you can write it here. You can write it. That is 1 by 1.6 into 10 to the power minus 19 is equals to n. So this 19 will goes to upside and will become 10 to the power positive 19 divided by 1.6. Okay, into 1. So you can do 1.16. So take 2 zeros from here. Okay, and then if you take 2 zeros, or you can write it, remove the decimal here and get 10 here. Okay, and still it is 10 to the power minus positive 19. So 10 into 10 to the power positive 19 upon 16. You get when you replace the decimal here, you just get this 10. Okay, now still you cannot read the table of 16 here. So get 1 0 from here. Get 100 into 10 to the power 18. Now this will become 18 because you add 1 0 here, and then 16. When you divide it, you will get 6.25 into 10 to the power 18. Your answer is also correct, but you have to take it up to 2 decimal place. Okay, 6.25 into 10 to the power positive 18 electrons. You understood? So
Yes,
this
sir.
number of electrons are going to constitute 1 Coulomb charge. Okay.
Okay,
So
sir.
let's move further. Okay, note this question. Calculate the number of electrons that will pass through a conductor per second when 8 Coulomb charge pass through it for the time 5 seconds.
So can you repeat?
Yeah, note it down. The question that is given to you. Note this question that is on your screen. Calculate the number of electrons that will pass through a conductor per second when 8 Coulomb charge pass through it for the time 5 seconds. Done?
Yes, sir.
Yes.
Okay. Okay. So here it is how we are able to take number of electrons that can pass through uh, a conductor per second. Time is per second means time is given 1 second. Okay. When 8 Coulomb charge pass through it for 8 seconds. So what is given to you? It is given that calculate the number of electrons you need to calculate when the charge is given 8 Coulomb charge and time is passing means total 8 Coulomb charge passes for 5 seconds. Okay. Time is 5 seconds. Okay. Got it? Understood? That calculate the
Yes,
number
sir.
of electron that will pass through a conductor per second when 8 Coulomb charge passes through it for the time 5 seconds. Okay. So if 8 Coulomb charge passes in 8 seconds, so you can calculate the current I is equals to Q upon T. And you know that Q is also equals to N into E. Okay, number of electrons. So you can write it First, you can calculate the value of I, that is I here, means you can calculate the value of I. Why you are calculating the value of I? Because if you know the current, okay, then current is actually the charge passing per second. Then you will be able to calculate the number of electrons. So first you need to calculate the total current that will pass, we can say that total current that will pass per second, okay, total charge that is passing through it. Okay, so we can write it, charge is given to you 8, you write 8, and time here is given, that is 5, write 5. Then I is equals to q upon t, so you write q upon t. Okay, got it?
Yes.
Then you divide it, you will get 1.6 ampere. So the current here is 1.6 ampere that is passing. Now what is being asked, that calculate the number of electrons that will pass per second. So you have to write I is equals to number of electrons, you write n and then E and upon time. Okay, the total. So if it is saying I is, you have noted, that is 1.6, write 1.6 here. Number of electrons you need to calculate into number, the charge of E, the value of E is, what was the value of E? 1.6 into 10 to the power minus 19 upon, what is asking, per second. It is not given any time. Don't write it 5 here, okay, because 5 was given. You're asking per second. Okay, so right here 1 only, okay, per second. Got it?
Yes, sir.
Number of electron passing per second. So you write here 1 in 1 second. Okay, then what you will do here, you will write 1.6 divided by 1.6 into 10 to the power minus 19 is equals to n. Got it? Then this will get cancelled, you will get 1, and then this will goes to upside, it will get 10 to the power minus 19 is equals to n. Okay, sorry, positive 19. So here the number of electron that will pass is 10 to the power 19 per second. Okay,
Okay, sir.
is there any doubt?
No, sir.
Yes, you Amar, you didn't understood because you leave the meeting, that's why, or are you getting each and everything?
Yes, sir. That's what I was going to say. So can you explain once?
Yes, I can try. Okay, so let me explain you that the relation between, it is said that I is equals to q upon t. This is the relation. Okay, q, and what is q? Q is charge, and who carries charge? Charge is carried by electrons. Okay, for example, if you have a biscuit, okay, and that is going to have, you have a biscuit packet of biscuit, and it is going to have, let's suppose 8 biscuit in a packet. Okay, okay, if you have a packet of biscuit and it is 8 packets in a biscuits. So if I told you that if you have 18 packets, so how many biscuit will be there in total? 18 into 8. If you have one biscuit has 8, one biscuit packets have 8 biscuits. One pack have 8 biscuits. So how many 18 such will have? So you will write 18 into 8 biscuits. Similarly, electron is going to carry, okay, let me explain you one more time, that charge is carried by electron. Charge is carried by electron, and the charge on electron is 1.6 into 10 to the power minus 19. Okay, got it? Got it?
Yes.
So let me explain you with this example, that if you have one packet of biscuit, then you have 8 biscuit. If you have 2, then you have 16. If you have 3, then you have 24. If you have 4, then you have 32. If you have 5 packets, then you have 40. Can you have, if you have it, is it possible that if you have 2 packets and you are going to have 20 biscuits? No, because 20 is not the multiple of 8. If you are having, you can have 8, then you can have 16, then you can have 24. You cannot have in between them. Okay, got it?
Oh, okay.
Got
Yes,
it?
sir.
For example, if you are collecting some rupees in your piggy bank or in a bank, okay, and you are just adding 5 rupees every day to it. So can you have 30 rupees, 32 rupees in that? 32 rupees? No. You can either have 30 rupees or 35 rupees, because you are just adding every day 5 rupees. Then only the total collection you are going to have is the multiple of multiple of 5. Okay, because you are adding 5 rupees every day. So you can have 30 or you can have 35. You can have 60 or you can have 65, but you can have 63. You cannot have 59. Okay.
Okay.
Okay. Similarly, if I'm talking about the electrons, electron is a charge carrier. Q is equals to N into E. Sorry, Q, we can write E is equals to 10 to the power minus 20. This is a charge of an electron. So if we have N number of electron, we can, means any object can have 1 electron, 2 electron, 1 lakh electron. Can it have 2.5 electron? No. Either electron can be divided, can be moved, 1 electron can move, 2 electron can move, 2.5 electron cannot move. So similarly, the charge on an object can be, it will be always integral, or we can say multiple of the charge of an electron. So if it is charge of an electron is 1.6 10 to the minus 19, then total charge on an object will be the charge of an electron into the number of electrons. Okay. So if we have 2 lakh electrons, then 2 lakh into the charge of the total charge will be N into E. Got it?
Yes, sir.
Got it. So the number of electrons that an atom is, or a substance is going to have, the total charge will be N into E. Got it?
Yes.
Yes, you also, Shama, you got it?
Yes, sir.
So the charge can be integral multiple. Note it down. Charge can be always integral multiple of an of integral multiple of charge on an electrons. We can have the charge, the possible charge can be 2e. The possible charge could be 5e, but the possible charge is 2.3 is not possible. This is possible, this is possible. If 5 electrons, if an atom get 5 electrons, then it get 5e charge. If an electron loses 2 electrons, that will get 2e charge. Then an atom cannot get or lose 2 by 3 electrons. 2 by 3 is in decimal, and how it is possible? So it is not possible. So the charge cannot be. Okay. So this is the formula that Q is equals to N into E. Okay. That is the total charge can be the number of electrons into the charge of an electron. Okay. And we can write I is equals to Q upon T. Got it? I is equals to Q upon T. Got it?
Yes, sir.
So we can write, we can also replace this formula by using I is equals to Q. Q is actually NE, so we can write NE by T. Okay. Got it? So what was the question? What was the question? That how many electron will pass per second? So what is being asked? Number of electron is being asked per second. Per second means time is asking for 1 second. Okay, per second. When 8 Coulomb charge, total 8 Coulomb charge passes through a conductor for the time 5 seconds. Okay. So what was it? Coulomb charge is given to you, 8 Coulomb charge, and how much time it is taking? 5 seconds. So what is the current flowing through it? So you can write I is equals to Q by T. Because if total 8 Coulomb charge flows per, what is the definition of current? The rate of flow of charge means how much charge per second electron, or sorry, through a conductor is being passing. So if I'm talking that what is current, so current is rate of flow of charge, means total charge that flows and the time divided by it. So if 8 Coulomb charge flows for 5 seconds, then you have to write 8 divided by 5. You have to write here, then you will get 1.6 ampere. You got it? You got it?
Yes, sir.
So if the total current that is passing per second is 1.6 ampere, so we can write it ampere. If I'm talking about 1 ampere current, so what does it mean? That 1 Coulomb charge pass in 1 second. Okay, it is just understood. This is nothing, but you can understand it by like this. That if I'm saying that 2 ampere current, so what does it mean? That 2 ampere current is flowing, 2 Coulomb charge is flowing per second. If I'm saying that 5 ampere current is flowing, so what does it mean? 5 Coulomb charge is flowing in 1 second. Okay, got it? If I'm saying through a conductor, if I note the reading of current in this conductor, it is 2.5 ampere. So what does it mean? That 2.5 coulomb charge is passing per second. Okay. What does it mean? It means that 2.5 coulomb charge is passing per second. You understood? So we get this charge, this current, that is 1.6 ampere current is passing. So I is equals to Q by T. You know this one. And Q is equals to N into E by T. T is 1 second because it is asking per second. And I is 1. Here it has been given to you. 1.6 you have calculated. So when you calculate it, 1.6 is equals to N you need to calculate. And the value of E is always fixed. That is 1.6 into 10 to the power minus 19. Mar, you got it? Then N will be equals to 1.6 upon 1.6 into 10 to the power minus 19. This 1.6, 1 point will get cancelled and this will goes to then you will get N is equals to 10 to the power minus 19. Sorry, positive 19. Got it?
Yes.
Amar, you understood?
Yes, sir.
Okay. So the next question. Do this question. Please note it that 1 milliampere is equal to 10 to the power minus 3 ampere. 1 microampere is equal to 10 to the power minus 6 ampere, and 1 ampere is equal to 1 coulomb per second. This can also be written. The 1 ampere, the other unit for ampere is coulombs per second. Okay, so please note it down and then note this question. And then please solve this question. This is important. Done? Done?
No, sir.
So are you doing this one?
Yes, sir.
Okay. The number of electron is given to you right now. Time is given to you. Current you have to calculate.
Where is the answer? 0.01 ampere.
Okay, what you saying? 0.01 ampere.
Yes, sir.
Okay, let's check. So calculate the current passing through 20. This number of electrons being given to you, so we can write it 20, 10 into 10 is about 20 electrons. Okay, so we can write it. First, we need to calculate the value of Q. Q is equals to N into E. Okay, and the time is given to you right now here. So you can write I is equals to Q by T, and the value of Q is this one. So write it. I is equals to N E by T. Number of electrons that is given to you, that is 10 to the power 20 into the charge of an electron is 1.6 10 to the power minus 19. Okay. And then this is time is 1440. Got it? Got it?
Yes, sir.
Then what we need to do here is, Ammar, you got it? When you multiply these two, what you will get?
Yes, sir.
10.
10 raised to the power only 10. Okay, because 19 will get cancelled, only you will get 10 raised to the power 1, and that is only 10. Okay, and it is 1.6 upon 1440. Okay, then what you need to do here is you have to cancel this 0 with this 0, and then again remove the decimals, and you will get 10 here. Now this is 16 upon 144 into 10. 16 1 is 16, 16 9s are 144. So you will get 1 by 90. This will get what you are getting here? You are getting
0.01.
yes. So you need to calculate I. So I is 1 by 90. 1 by 90. Okay, 0.01. Yes, you can. So when you divide 1 by 90, you will get point, then 0, then still you cannot read the table, then 0, then 1, 0, then 1, you will get 90, and again 10, then 0 is here, then you will get 0.011 ampere. Okay, it is correct. Your answer is correct. Okay, understood?
Yes, sir.
Understood? Ammar, you understood?
Yes. Yes, sir.
Next question. Note it down the device used for measuring ampere, and the current is ampere meter, and its symbol is denoted by this A, and it is always connected in series and have low resistance. And why? We will discuss this later. Okay, when we will learn the series and parallel combination of resistance and what is resistance. So we will learn it later. But note it down that it is always connected in series and have low resistance. We're talking about ampere meter. Okay, and it has low resistance. Okay, and then note this question. And then solve it. Done?
No, sir.
Noted. Then may I solve it for you? A current of 1 ampere. So current is given, that is 1 ampere, I is 1 ampere, is drawn by a filament of an electric bulb. The number of electrons passing through the filament in 168 seconds would be roughly. So if I talk about this one, number of electron is being asked. So I is equals to Q by T. Okay, Q by T, and Q is N into E and T. Okay, so you can write this formula. So I is given that current drawn 1 ampere by a filament. So you write it 1 ampere. And here N you need to calculate is 1.6 into 10 to the power minus 19 upon what is being given to you. That is time is 168. Okay. Got it?
Yes,
Got it. So
sir.
this will goes 168 and this will goes to multiply for this multiplication and this will comes down. You will get 1.6 into 10 to the power minus 19 into, sorry, 1.6 into 10 to the power minus 19 up is equals to, and what is N? N is this. Okay. Then what you will going to do here? You remove this decimal and you will get extra 10 here. And this will goes upside. Okay. So what you will get? 10 is to the power 20 into 168 upon 16. Got it?
Yes.
So approximately when you divide it, you will get 10 times approximately. Now
Yes, sir.
you will get 10.5 times. Okay. So it is not given. This is 10 to the power 20. But the next is 10 to the power 23. So the answer will be in 10 to the power 21. Okay. But since the answer is 10 to the power 20 is after this one is 10 to the power 23. So we'll closer to this one. Okay. So it is asking
Okay, sir.
roughly. So this is the answer. Okay. Got it?
Yes, sir.
So that's all for today. We'll meet you in the next class. We'll practice some more questions. Okay. And the next class will be going to very